Okay, my dear friends. So, space physics is under our discussion, is the topic which we are discussing. And we will be talking about the solar system because the last topic was about this orbital velocity which we were discussing, and many questions are there which we can solve on this orbital velocity. Now, solar system consists of the sun, of course, 8 planets, natural and artificial satellites, all details will come, dwarf planets, asteroids and comets. Now, these are the parts of the solar system. In general, we just talk about the sun and 8 planets, but there are many other things. Like 3 more things are there which are related to the solar system we belong to. The sun and the planets. The sun lies at the center of the solar system. And the sun is a star that makes up over 99% of the mass of the solar system. Like just an example, I would like to say that if the mass of the whole solar system consisting of these 5 major parts, mean the sun itself, 8 planets, natural and artificial satellites, dwarf planets, asteroids and comets. For all of them, let's suppose mass is 100 kilogram, which is just a supposition, it's not the exact correct value, of course. So mass is, let's suppose, 100 kilogram, then 99 kilograms are contained within the sun only, and rest 1 kilogram is distributed among the 8 planets, natural and artificial satellites, dwarf planets and asteroid and comets. So major or almost all amount of mass is there within the sun. Okay. So now one thing more here, it will be repeated again and again. The planets, the 8 planets around the sun, their orbit is almost circular or near circular, and the sun is at the center, and the sun lies at the center. But for some things like comets, asteroids and comets, like comets, their orbit is not circular, their orbit is elliptical, just like the shape of an egg, elliptical. And sun, whenever something is revolving around the sun in an elliptical orbit, it means sun will not be at the center of that orbit, it will be at a side. So remember this thing because you may find many MCQs on this topic. There are 8 planets that are known, and an unknown number of dwarf planets, both will be discussed now, which orbit the sun. The gravitational field strength around the planets like the Mercury, Venus, Mars, Earth, Jupiter, then Saturn, Uranus and Neptune, they are all having a strong or quite enough gravitational pull. So the gravitational field around the planets is strong enough to have pulled in all nearby objects with the exception of the natural satellites. That's why if any one of us is planning that I can get rid of Earth's field if he is jumping from some height within the field of the Earth, so of course only one way he has to move or she has to move, that is toward the center of the Earth, because gravitational pull is strong enough, gravitational field is strong enough. This is for the all nearby objects, nearby masses except the natural satellites, and one of the example of the natural satellites is the moon. Moon is not, of course, like Earth, is providing the gravitational field or gravitational pull, which is becoming the centripetal force for the sun to orbit around the Earth, centripetal force for the moon to orbit around the Earth, but it cannot attract the moon towards itself in general. So artificial satellites are many that will be discussed later in today's lesson, inshallah, but natural satellites example is like moon, and different planets are having different number of moons. If I'm not wrong, this is simple, some sort of memorization. I think Jupiter has 11 moons around it. So all the moons are the basically natural satellites. The gravitational field strength around a dwarf planet is not strong enough to have pulled in nearby objects, and there is a countless number of dwarf planets. Pluto. When I was studying this IGCSE, mean this level or even A level stuff, so in those days Pluto was the part of the solar system, and we were remembering that there are 9 planets around the sun which are revolving around the sun. Pluto, it was very far away from the sun, and its gravitational field strength around the Pluto was very weak. So it is also now considered as the dwarf planet, not the planet in general, dwarf planet. So the difference between a planet and dwarf planet is just in case in terms of their gravitational field strength. Planets are having a strong enough gravitational field, whereas the dwarf planets are not having a strong enough field around them, so they cannot attract the nearby objects. The next is the 8 planets in our solar system in ascending order of their distances from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are all 8 planets in order, and let me tell you, the first 4 planets, they are rocky, mean solid, high density, like this I can say. The last 4 planets, they are gaseous and low density, of course, as compared to okay, now they have low density. Now let's talk about one by one slowly this about the satellites. Some planets have moons which orbit them, and moons are an example of natural satellites. Then artificial satellites are man-made and can orbit any object in space, like the International Space Station ISS that orbits around the Earth is an example of an artificial satellite. There are many telecommunication satellites are there, which are through which the transmissions are done for different television channels and satellite communication, even navigation, mobile signals. A lot of satellites are there, and they are all for weather forecasting. So these are all artificial satellites. Not a big deal. Now, asteroids. An asteroid is a small rocky object. Asteroid is a small rocky object which orbits the sun. Rocky objects which orbit the sun. The asteroid belt, see what a nice word is used, lies between the Mars and Jupiter. So these asteroids, they are not very close to, these rocky objects are not very close to Earth. After Earth, this is Mars, planet Mars, and then between the Mars and Jupiter, the belt of the asteroid is available, is present. Now see the use of belt. Even the belt which we are we are using in our pants around the neck, that is also like an orbit around our body. Belt which are rotating different parts of the car engine, it is also like the meaning of an orbit. So asteroid orbit or asteroid belt lies between the Mars and Jupiter. Then the comets. Comets are made up of dust and ice and orbit the sun is a different orbit to those of planets. So it means they are not moving in circular orbits, they are moving in elliptical orbit. I will go to that point, just wait for a moment. The ice melts when the comet approaches the sun and forms the comet tail. I will show you this one now in few moments. Now, rocky planets, there are 4 rocky and small planets, and what they are? They are Mercury, Venus, Earth and Mars, and they are nearest to the sun. 1, 2, 3, 4. Like this is their order from the sun. Gaseous planets, there are 4 gaseous large planets. Jupiter, number 5 from the sun, then Saturn, Uranus and Neptune. These are furthest from the sun and they are gaseous planets. Now, comet and comet tail. I would like to share this thing. And in general, these asteroids, these rocky objects, they are not coming towards the earth, but the from this I think Hubble Space Telescope, they have found that one rocky object is moving towards earth and it may hit on 22nd of December 2032 the earth. And not very hot topic in the NASA, because I have liked or I have subscribed that the page of NASA on Twitter, so they are and also European Space Agency. So many days they are. No, yesterday European Space Agency said that no, there is very rare chance, only 1.5% chance is there that it will hit the Earth, and two or three cities are there in Africa where it can hit, and two are in Asia, like South Asia, like one it is possibility of Mumbai, Kolkata and Dhaka, the Bangladesh capital, and one maybe in North America, somewhere like this. So there is a possibility it will hit. In general, they are not coming. It's about I think 60 meters wide. So if it will hit any of the city, so more than half of the city can be destroyed. But what is the plan? Right now they are calculating by seeing its speed and its duration, speed, angle and everything, the way it's moving. Few days back when the NASA announced, they said it will hit definitely, then the probability went down, and yesterday's European Space Agency, they told no, it will be only 1.5% chance it may hit the earth. And they name also some cities. You can check it, you can Google it on Twitter, you can Google it on Gmail, you can Google it on internet, whatever. And now they are also planning now, if there will be high chances, because it is very far, it is the matter of few years to hit the earth if it is going to happen. So they are planning that they should destroy this rocky objects in the space, such that it will become or converted to small pieces, and then there will be very less chances of any damage to the cities on the earth anyhow. But in general, these rocky objects are in a far off place, like from earth. After earth there is Mars, and between Mars and Jupiter there is a belt or the orbit of these asteroids. Something very interesting, these they are been trying to knock, trying to, they cannot stop it, but they can break it on its path if it is moving closer to the earth with a high ratio of or high probability of hitting some city on the earth. Comments I would like to share with you, because important many questions you will find out here come here for the orbits and conservation of energy. Something is in front of you, and what can you see? Orbits and conservation of energy. This is the comet. You know, I told you it is made up of dust and ice. So as it is approaching closer to the sun, due to enormous heat it is receiving or the high temperature, the ice melts and makes the tail. That's why this red part, you can say the dust, and this one which is, you can say, flying backward but not separating, that is the tail. So when it is coming closer to the sun, gravitational pull of the sun on it is very fast, very high, so it is moving faster. See, it is written fastest here. When it approaches closer to the sun, this comet, it becomes fastest. If it is becoming fastest, it means its kinetic energy will be maximum. It means its kinetic energy will be maximum. Kinetic energy will be maximum. Okay. So as kinetic energy is 1 over 2 mv square, so kinetic energy is proportional to what? Square of speed. So when speed is less, sorry, here when speed is more, kinetic energy is maximum, but see its height or distance from the sun very less, so GP is minimum. Then with this high speed it flung back into the space and reaches to the maximum distance here, such that height becomes maximum over here, so its GPE becomes maximum, and as the gravitational pull on this comet and its tail is least, so speed will be less and kinetic energy will be minimum. But throughout this phenomena or throughout this orbit, you can say one thing, that the energy is conserved, that when kinetic energy is maximum, potential energy is minimum, but the sum of kinetic and potential stays the same throughout this orbit. And this blue orbit, blue circle or elliptical spot, this is the orbit of a comet, which is not circular, this is elliptical. And you can see two circles, one is blue, other one is black. In the black, planet is shown there. And in case of this planet and the circular orbit, sun is almost at the center of this black circle, but sun is at the edge of the blue circle or orbit, like this. Better to say orbit. So remember always, as I told you in the beginning, this will not be written into the notes, this will not be there into the books, but of course it is a very typical common question. Planets orbit in near circular orbits. So there the sun is at the center of those orbits. But if it is we are talking about the comets, so their orbit will not be circular. Sun will be on one side of that orbit, like in this case you can see this blue one orbit. And throughout this motion of the planet around this sun, motion of the comet around this sun, energy stays conserved. And whatever I have said, don't worry, everything is written here. Although an object in elliptical orbit like this comet, such as a comet, continuously changing its speed, its energy must be conserved. Even it is changing its speed continuously, but the energy is what? Conserved. Just give me a moment, my dear students. Okay, my dear students, now you can observe that everything which I was sharing with you, that is mentioned here, that is written here. Although an object in an elliptical orbit such as comet continuously changing its speed, its energy, but still must be constant. If it is changing speed, it means it is changing only kinetic energy. And kinetic energy is being changing, so of course potential energy is also dependent, so it will also be changing. Let me say dependent. So throughout the orbit, the gravitational potential energy and kinetic energy of the comet changes, but some of these two energies will stay constant to conserve the energy. As the comet approaches the sun, it loses gravitational potential energy and gains kinetic energy. The reason, as I shared with you over here, that when it approaches to the sun, height or the distance between the comet and the sun is minimum. So GPE is directly proportional to the distance or height from the surface of the body. So GPE will be minimum, but that loss in GPE is converted to gain in KE, and as a result, kinetic energy increases because speed increases and GPE decreases. And that's what is mentioned over here. Again, I'm reading, as the comet approaches the sun, it loses gravitational potential energy and gains kinetic energy. This causes the comet to speed up. So this increase in speed causing a slingshot effect, like you pull the paper bullet in class around the rubber band, like you know what we are doing in general, the boys, the girls in classes, like rubber around your thumb and the forefinger, paper bullet pushed back, stretched back. Now this is a flung. As you will let it go, so it will flung, it lose. So this increase in, what can we say, this increase in speed causes a slingshot effect, and the body will be flung back into the space again, having around the pass, or having passed around the sun, so going to the maximum height. As the comet moves away from the sun, it gains gravitational potential energy and loses kinetic energy. This causes it to slow down. So reverse will happen. But Eventually, it will fall back toward the sun once more. In this way, a stable orbit is formed. And if there is a question how a stable orbit is formed, so you will follow, you will write all these things in your own words, that when somebody is closer to the sun or even earth even, let me say, so speed will be maximum, gravitational potential energy will be least, and kinetic energy will be maximum. Kinetic energy will be maximum, gravitational potential energy will be minimum, but the total energy will be conserved. So the stable orbit will be formed. Please, if any one of you is having any question here, feel free, you people can ask me now.
Yeah.
Okay, my dear friends. Now I will be discussing with you quickly one thing. These important things are there. You can memorize them yourself. But my concern right now is about this table. Yes, Lajin, you raise your hand.
I wanted to ask that that part of space physics has no calculations, only like
No, no, there are
structure.
calculations. It means you are asking me. No, there are numerical problems. There are many calculations.
Okay.
Not too much like in general physics or in electricity magnetism. Like you have to calculate light year, you have to calculate orbital velocity, and you can be asked to calculate the age of the universe. These are the three hot topics which are there in the exams for last 2 years, at least. Then 3 plus 3 6, yeah, 6 exams till now, and almost 6 exams mean uh, many papers, 10 plus exam papers are there. So these three calculations are most common, rest it is theory based. I think that's what you asked me. Okay, now come to this table. I want to share few things quickly here. Now see, this is the table of data for planets in our solar system. Mercury, see its distance 57.9, but it is million kilometers. Million kilometers. On the other hand, Neptune, too far, 4,495.1 million kilometer. 4,495.1 million kilometers. Now, the effect of this, come here. It takes only 88 days, who? Mercury, to orbit once around the sun. Whereas, Earth, we know, it takes 365 days to orbit once around the sun. But Neptune, it takes 165 years to orbit once around the sun. Why so? Two reasons are there. I will say it, and then they are written also in these notes. Number one, Mercury is closer to the sun. The radius of orbit of Mercury is small, so its circumference is also small. Because it is closest to the sun, Neptune is almost 9 times further away from the sun as compared to Mercury. So the radius of orbit for the Neptune, what is the radius of the orbit? It means the distance from the center of the sun to the center of Neptune. That is too long, too much more. So the circumference, the orbit of the Neptune is very far, it is very long. So Mercury has to travel smaller distance to orbit around the sun. Neptune has to travel longer distance, much longer distance as compared to Mercury to orbit around the sun. So of course it will take longer time. One reason. Another reason, always remember, like even you have seen now in the case of comet, as it approaches towards the sun, it moves faster. So the planets which are closer to the sun, so gravitational pull of the sun on those planets is more, so orbital velocity is also more, so they move faster. Whereas Neptune is furthest away from the sun, so it's so the gravitational pull of the sun on Neptune will be weaker as compared to Mercury, so the orbital speed of Neptune will be very short as compared to the Mercury. So two reasons are there, that Neptune is taking 165 years to orbit once around the sun. One, its radius of orbit is more, so its circumference is more around the sun, so it has to travel longer distance. Secondly, as it is furthest away from the sun as compared to all other planets, so gravitational pull of the sun on Neptune is weaker, so the orbital speed of the Neptune is also small, so it has to travel longer distance at smaller speed, so it takes longer time. Whereas Mercury has to travel smaller distance with greater speed, so it takes shorter time. And if you want me the speed difference, come here, there is another table here. Now check here, for Mercury the orbital speed is 47.9 kilometers per second, whereas for Neptune it's very small, almost 9 times small, 5.4 kilometers per second, whereas Earth, it orbits around the sun at a speed of 29 kilometers per second. So very important point these are, and you have to remember them. Now one or two more things quickly. Now check these first 4 planets. They are all rocky, and see their density is on the average 5000, but this Mars is having a density of 3933, which is almost 4000 if we round it off to nearest 1000. Earth maximum 5514, and rest all other planets, they are gaseous and their density is less. Now another thing, why Elon Musk, SpaceX owner, NASA, European Space Agency, and even some people, I think they are willing to go to the Mars from United Arab Emirates. Why Mars? Density more, and check the temperature over the surface. Surface temperature for Earth it is 20, but for Mars minus 23. Even right now in my country, Pakistan, there are some areas where the temperature is below 20s, minus 20 and in between minus 20 to 30 degrees Celsius. Siberia, a part of Russia, where the average temperature in winter, that is minus 50 degrees Celsius, so it means minus 23 degrees Celsius is livable temperature. So that is the matter of attraction, that after moon, the next destination in space, in the outer space, that is the Mars. Another thing here. Now see, as we move away from the sun, temperature decreases. See 350, other than this 20, then minus 23, minus 120, and temperature is decreasing. Only this trend is not followed by Venus. What is the reason for that? Venus has a very dense atmosphere of carbon dioxide gas, and carbon dioxide is one of the gas playing a vital role in greenhouse effect, so it traps the heat. So the temperature, even it is almost 2 times further from the sun as compared to Mercury, but due to that carbon dioxide atmosphere, greenhouse effect traps the heat, and its temperature is even higher than Mercury. So this was very important, which I was willing to share with you people. Now let's read. All these things are in the written form also. Orbital duration. How long it takes to travel around the sun increases with orbital distance from the sun. That's what the first point I was sharing with you. So orbital duration increases with orbital distances. For example, Neptune travels much slower than Mercury. Why so? The planets which are further away from the sun experience a weaker gravitational pull, so move slower in their orbits. So 2 reasons which I shared with you, they are written here. 1, longer distance. As the planets are away from the sun, radius of orbit is long, so their circumference is more, so they have to travel more distance, and also they move slowly because gravitational pull gets weaker. This is one point. No need to memorize any values, Mahana. They will give you. Don't worry at all about this. Now see, the second point which I was just discussing with you in the end, that the surface temperature decreases with orbital distance except for Venus. Why not for Venus? Venus has a dense atmosphere of carbon dioxide trapping in heat through the greenhouse effect. Then last thing about which I forgot to share with you people. See here, these are the gravitational field strength, which is the value of G at different points. The surface gravitational field strength does not depend on a planet size. just depend on a planet size but also its mass. So the value of G depends on planet of size of the planet and also the mass of the planet. That is the why Uranus is 4 times larger than Earth. It has a smaller gravitational field because it is less dense. It is less dense. It means it is having less mass. So the value of G, gravitational field strength, it depends upon the size, but majorly it also depends on the mass, or you can say density. So these are some important points. If you have any question regarding any one of them, please feel free. You people can ask me now. Okay, my dear friends, stay blessed. We will be having a break of 7 minutes for prayer right now.